Now I am going to discuss a question from Pathfinder, chapter Laws of Motion, question number 21. According to given question, one end of a light inextensible cord is attached to a nail A on the ceiling. The cord passes through frictionless hole of a small bead P. Thereafter, it passes round two ideal pulleys and finally the other end is attached to the bead. Initially, the bead is held at rest with the cord segments AP and BP making angles alpha and beta with the horizontal while keeping the segment CP vertical as shown in the figure. Find acceleration of bead immediately after it is released. Acceleration due to gravity is G. Now I have redrawn the circuit. You can diagram. You can see here. According to question, we can see that there is a one thread. There is a nail here. We can see according to this. This is a nail A. Now this thread is going from here, going like this, and I made small hole to the disc, whatever the disc is given now, that disc I have taken like a small hole here. Through the hole I have passed this string through the pulley 1. Now from pulley 1 to pulley 2, again it is connected to the surface of the disc. Okay, now what I am doing is, so I am taking like a what are the forces, actually what are the forces acting on the body. Okay, we can see here the forces acting on the body is one time. We can see here tension T throughout the string. Same tension will be there throughout the string. I have taken here tension T, here tension T, here tension T. Now if I draw the free body diagram of this body, I am drawing a free body diagram of this disc. So according to the question, we can see the tension force is acting upward direction T, and one more thing we can observe that this is making angle alpha, here also making angle beta. I can write the components of these forces along this line is T sine alpha, T sine beta acting along the y-axis. So net force along the y-axis is upward direction is T plus T sine alpha plus T sine beta. Similarly, along the horizontal direction, you can see the net force acting towards the left side is T cos alpha plus T sine beta, and weight of this disc I am taking as mg. Just after release, we can see that due to the weight, it is going downward direction. I am taking acceleration along the y-axis is ay. Similarly, due to the T cos alpha and T sin alpha, I am treating the disc is having acceleration ax along the x-axis. Okay. Now I am going to apply the force equations along the x-axis and y-axis. As you know, the summation of f of x is equal to m into ax. I am writing now the net force acting along x-axis is equal to T cos alpha plus T sin, sorry, this is not the T sin, this is T cos beta. We can write here T cos beta is equal to m into ax. From this we can write it as acceleration along x-axis can be written as you can write this as T into cos alpha plus cos beta whole divided by the m. This is the ax value. Similarly, I am writing ay value. Summation of f of y along y-axis is net force along the y-axis is m into ay. Mass is m. We can write it as the disc is going downward direction, we can write it as downward force mg is minus upward force we can write it as T taken common. Now we can see 1 plus sin alpha plus sin beta is equal to m into ay. If I write the ay value, g minus t divided by the m, 1 plus sine alpha plus sine beta. If I write g minus ay value, I will get the g minus ay value as t by m into 1 plus sine alpha plus sine beta. This is my actually you can see vertical acceleration g minus ay as well as horizontal value also I have written x. Why I wrote g minus ay now? To cancel this t by m values. Reason is in the question they are not asking what is the tension in the string. They are asking find the acceleration of the bead immediately after string is released. But if we see in this equation 1 as well as equation number 2, equation 1 and equation 2, we can see that unknown terms are we can see t is unknown, ax is unknown, ay is unknown. These are unknown terms, but we are having only two equations. Only two equations are there. So to solve these three unknowns, we need one more equation. That equation is a constraint equation. Constraint equation. I am taking now constraint equation. Now you can see what is a constraint equation. According to constraint relation, you observe this properly. What is a constraint equation? I am going to see now. According to this, the net work done by the tension force is equal to 0. So I can write it as summation of t into acceleration also 0. Now, if you see that on the disk, the net tension force along this direction is t cos alpha, along x-axis is t cos alpha plus t cos beta. And the net tension force along the y-axis is t into 1 plus sine alpha plus sine beta. I have taken acceleration is a downward direction along the y-axis, and acceleration on x-axis I have taken left side. So if I apply the tension constant relation, t into cos alpha plus cos beta into ax cos 0 degrees plus again t into 1 plus sine alpha plus sine beta into ay into cos 180 degrees is equal to 0. Now if you apply this, t into cos alpha plus cos beta into ax cos 0 is 1, next minus t 1 plus sine alpha plus sine beta into ay cos 180 degrees already I have written minus 1 is equal to 0. I can write this as t into cos alpha plus cos beta into ax is equal to t into 1 plus sine alpha plus sine beta whole thing into ay. T and t get cancelled. If I cancel t and t, I can get the value as a y divided by the ax, that is equal to cos alpha plus cos beta whole divided by the 1 plus sine alpha plus sine beta. This is my ay by ax. Why I am writing ay by ax value? You can see here. This is my ax, this is my ay along the y-axis, and net acceleration you can write it as a. As per this question, we can see the net acceleration is, let us consider making angle theta. So now you can write tan theta is equal to ay divided by the ax, that value is cos alpha plus cos beta whole divided by 1 plus sine alpha plus sine beta. Okay, you keep it as one equation. Now you observe this carefully. In the question we can see we got like a equation number 1 and as well as equation number 2. Okay, now we are writing equation 1 divided by the equation 2. Suppose if I write equation 1 divided by equation 2, I can get this as ax divided by ay is equal to cos alpha plus cos beta whole divided by the actually this value is g minus ay is there. Equation 2, if you observe that, I have taken this as g minus a by y. Now you will get the t by m, and t by m is there. Now here also I will get t by m, and here also I will get the t by m. 1 plus sine alpha plus sine beta. If you want, you can see here again, equation 1 is t by m cos alpha plus cos beta. Similarly, second equation is g minus ay is equal to t by m 1 plus sin alpha plus sin beta. Now, I am writing this as t by m and t by m, both t by m's are get cancelled. So finally, what value will get? Cos alpha plus cos beta whole divided by the 1 plus sin alpha plus sin beta. This is my value of cos alpha, ax divided by the g minus ay. Let us consider this is the third equation, and whatever I have written now is fourth equation. If you compare the third equation and fourth equation, compare equation 3 and equation 4. If you compare both the things, I can write it as ay divided by ax is equal to ax divided by g minus ay. So from this you can write it as g into ay minus ay square is equal to ax square. So from this I can write it as ax square plus ay square is equal to g into ay. As I know that whenever this you can see here, bead is immediately after bead is released, after releasing it immediately, we can see that acceleration due to gravity is there, and net acceleration also there. I am writing now whatever net acceleration from this relation, a is the net acceleration, ax is the horizontal acceleration, and vertical component is ay. So I can write it as ax is equal to a cos theta. Similarly, ay is equal to a sin theta, and a is equal to under root of ax square plus ay square. I can write this is a square is equal to ax square plus ay square. Now substitute all these values here. If you see that ax square plus ay square value is a square, g into we have like ay value is equal to how much? A into sin theta. Now we can see that this a and a one time get cancelled. Finally, I will get the our required acceleration of the bead just after it releases. Okay, a is equal to g sin theta. Okay, and I calculated that tan theta value. We can see from this we can write it as theta is equal to tan inverse of cos alpha plus cos beta whole divided by 1 plus sin alpha plus sin beta. So as per the Pathfinder solution, key whatever they have given is a is equal to g sin theta, where theta is equal to tan inverse of cos alpha plus cos beta whole divided by 1 plus sin alpha plus sin beta. So this is a very nice question. You can see here how to write the constraint relation. We have to see that how to write the constraint relation, and how after whatever the disk is just released, how this bead is moving. You can see actually whatever bead is there now, that I am calling this as a disk shape. Why? Because I have written this as a disk shape now. That's why I am calling this bead as a disk. I hope everyone understand this, and the final answer also you can check that a is equal to g sin theta, where theta is equal to tan inverse of cos alpha plus cos beta by 1 plus sin alpha plus sin beta. Thank you.